Physics and bio. Not chemistry. Hello. Shall we start now? Now, fountain experiment. How many of you want me to explain to you the fountain experiment? All of you know the fountain experiment? You don't know. You were absent for HCL. I think you came.
I'm here from first section.
Huh?
You were asking for the first section.
Now we have the fountain experiment. The fountain experiment proves that ammonia is basic in nature and ammonia is highly soluble in water. Okay, so we have got the fountain experiment. Looks like this. Now it's like this. You have the this is water. Okay. Now, then you have a thin capillary. This is a capillary. Okay. And then this is the flask. Okay. Now, this flask has got ammonia gas. Ammonia gas, which is colorless. This water is actually red litmus. I should have put red water here. Not water, but it is red litmus solution. Okay. Now what happens is here atmospheric pressure is acting on the surface of the red litmus solution. The red litmus solution goes up right here. It goes right up here, right up here, right up here. This is a capillary. And with the force, it will reach up here and burst out in the form of a fountain. It will come out in the form of a fountain. But what happens is this red litmus solution, when it comes in contact with ammonia, it will become blue. It comes as a fountain and becomes blue. The red will become blue. Why? Because ammonia is basic in nature. Okay? So this is no more gas. It now become liquid. What color liquid? Blue. And this is your red litmus solution. Getting up because of the atmospheric pressure which is exerted on the surface of the liquid of the red litmus. It pushes it up the capillary. It reaches here. At this point, immediately the gas comes in contact and it becomes blue and it comes out in the form of a forceful fountain. That is how. So this proves that ammonia is basic in nature and it is highly soluble in water. Any problem? Okay. Now we come to the next one. And that is here. chemical properties of chemical properties of ammonia. First one, ammonia does not support combustion, but it burns in oxygen. It does not support combustion, but it burns in oxygen. Okay?
But here it is written that it is neither combustible nor is a good combustion.
It doesn't catch fire. Alone it doesn't catch fire. It catches, it is with oxidized. It gets oxidized with
So-
the presence of oxygen.
So when substances said that they are combustible, means that they burn even without an atmosphere of oxygen.
Your petrol, it doesn't need oxygen. It burns. It's combustible. Okay? So you have to remember that it is neither, it doesn't support combustion, but it burns in oxygen.
Even hydrogen.
Hydrogen is highly combustible. It burns in oxygen.
Even without oxygen.
No, it will burn. No. Hydrogen needs oxygen. Hydrogen needs oxygen. Now see, ammonia is not means does not support combustion, but it burns in the presence of oxygen. What do you get? You get ammonia plus oxygen will give you nitrogen plus water. This is a yellow flame, a yellow greenish flame, a yellow flame. Okay. Now what happens is the experiment is like this. You have a gas jar. You have a gas jar, and you have ammonia here in a very tall tube. Okay, in a very tall tube. And you have oxygen here. Okay, now this is your oxygen. The oxygen is coming out here, and what happens is your ammonia is getting into this tube, and this oxygen, in the presence of oxygen, it catches fire, and you're getting a yellow color flame at the top. Ammonia catches fire or burns in the presence of oxygen. Okay, to give you a yellow flame, to give you the yellow flame of nitrogen and water.
Answer is ammonia flammable.
Pardon me?
Is it flammable?
Inflammable.
Yeah, so
In the presence of oxygen. Like that, you keep it, it won't catch fire. It is not a supporter of combustion. It is not combustible. But in the presence of oxygen, you're getting this reaction. This reaction is reversible. This reaction is reversible, and it is exothermic. It gives out a lot of heat. Exothermic reaction. Highly inflammable, meaning highly inflammable. In other words, in the presence of oxygen. So it is an exothermic reaction, and it is a reversible reaction. What do you want to say?
why is the outlet for oxygen shorter than that of?
Pardon me?
Why is the outlet of oxygen shorter than that of?
Oxygen is heavier. Ammonia is very light. So right here, if we want to see that this is the flame, it may burst into a very big flame, no? So we have a very thin thing. Let us see this reaction right on top there. Aram se. Not for any reason. It's just for you to see. It is instantaneous because it's exothermic. So therefore, they have put along so you can see nicely. Okay, the ammonia burning away from oxygen. Oxygen is here. It's very heavy. Okay, it's very heavy. This is light, so it can go very high. So we have put the tube high. That's the only explanation I can give you, nothing else. Only because there could be explosives, because it's an exothermic reaction. So therefore they kept it so high, so you can distinctly see the yellow flame. We want to see the yellow flame of the nitrogen. We don't want to see the yellow flame of a reduction. We don't want to see the yellow reduction flame. Yellow flame is reduction flame now. The reducing flame is yellow now. You've got your burners in the house. What is the color of the burner flame? Blue. That's an oxidizing flame. It is very, very hot. There is but no light. You put rice in that flame, or you put milk, suppose the handi the milk overflows. What is the color of the flame? Yellow. That is a reducing flame. It is a bright flame, but it's not hot. Okay, it has a lot of carbon in it. And that carbon is making it a reducing flame. I will explain that to you when I'm teaching you organic chemistry. So you are likely to get a reducing flame here at a lower level. We want to see the yellow of nitrogen, not the yellow of a reducing flame. The yellow of the reducing flame is actually goldenish yellow. But the yellow of the nitrogen is very pale greenish yellow. That can be it could be camouflaged if it's put so low. Therefore, it is taken higher. Is this clear? Follow? So this is your reaction with ammonia in the presence of oxygen. What are you getting? You're getting nitrogen and you're getting water. Now I'm going to show you ammonia burning in the presence of oxygen, but also it is a catalytic reaction. This is no catalyst here. Is there a catalyst here? Not at all. So without catalyst, you're getting nitrogen and water. With the catalyst, you're getting a different reaction only altogether. What is it? I'll tell you. Suppose you have got this is said to be an ignition tube. It's an ignition tube. It's an ignition tube. In this ignition tube, you are putting oxygen. Oxygen is being allowed here. And in the same ignition tube, okay, you are having another outlet of ammonia. Ammonia is allowed to enter here and oxygen is allowed to enter here. Correct? Here you have got platinum heated at 800 degrees centigrade. Very, 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 very hot, red, hot platinum. 800 degrees centigrade. Ammonia is getting in, oxygen is getting in, and ammonia plus oxygen is giving you NO plus water. You're getting NO here and water collected here. But this water will evaporate because the temperature is so high. This water will evaporate because the temperature is so high. But as long as this is continuing, you will get this water because the reaction is still continuing. Correct? Now, this NO combines with more oxygen and gives you NO2. This NO2 is brown fumes. Brown fumes. So here what happens, brown fumes of NO2 get collected in a round bottomed flask. These are brown fumes. So you see here, ammonia and oxygen without a catalyst is giving you yellow flame of nitrogen and water. Ammonia and oxygen with catalyst, okay, is giving you different products. So the ammonia plus oxygen is giving you NO plus water. NO combines, there's NO here. NO combines with more oxygen to give you NO2. This NO2 are brown fumes. So ultimately, the end result is brown fumes of NO2 getting collected in that round bottom flask. This is with catalyst. This is a highly exothermic reaction. So after some time, we cut out the heat. It is heated here. It is heated by now. It is heated here. Okay, but after some time, it is an exothermic reaction. It generates its own heat, so we cut out the heat. Okay,
So they asked the question, which gas is released during the catalytic oxidation of ammonium dioxide nitric oxide?
Two steps. Two steps. Two steps.
But if it is in an MCQ, and they give us nitrogen dioxide,
then you have to put NO2. Fine. Then it's fine. They won't give you such a tricky thing. It must have come from the school, not from the board. If it comes from the board, you put both the ticks, you will get your answer, you will get your marks for attempting the question. Because there's a fault in the question. If you attempt a faulty question, you will get your full marks if it is coming from the board. In your school, Don't be bothered. Although, attempt it. Last time also there was a problem in one paper. I can't remember the paper. I think it was in CBSE. But you all also had a problem.
No, 12 hours.
Huh? Something, there was a, 12 ICSE paper.
12 hours. English.
When was it? It was a Tempest. Tempest, so it was,
Probably our English teacher was telling us.
maybe I can't remember that. Okay, but then you get your full marks. So if you get that type of thing, attempt it. You get your full marks. Okay? So you got this now. Now what are we understood is the production of nitrogen and water without catalyst and production of NO2 with catalyst. This is clear reaction, both ammonia with oxygen. Conditions apply. Got that? Shall I go ahead? I want to read so far what I've taught you. Huh? You want to read up to what I've taught you, or do you want me to go ahead? I go ahead? Okay. Now we got ammonia is a, I'll rub this out. I'll rub this out. Ammonia is a very good reducing agent. Very, very good reducing agent. And this will come in the form of reaction of ammonia with copper oxide. Ammonia plus copper oxide. This is going to be reduced. What are you going to get? Copper plus nitrogen plus water. This is what you're going to get. You don't have to bother about lead oxide. You only have to be bothered about reaction of ammonia with copper oxide, not with lead oxide. Okay? Now here, pay attention here. What it is here, you have got again a ignition tube. Okay? This is ammonia. Ammonia being passed inside. This is copper oxide. This is copper oxide. Okay? And there is heat here. And this is being heated. Okay? Alright? Now, ammonia combines with copper oxide. And what you're going to get, oxygen, nitrogen, and hydrogen are coming out from here. Nitrogen and hydrogen, nitrogen and water are coming out from here. Now, what is left here is copper. Copper oxide has become copper, so copper is here. Your ammonia has been converted into nitrogen, reduced to nitrogen. Sorry, oxidized to nitrogen. Ammonia has got oxidized to nitrogen. Hydrogen is taken away, so it got oxidized to nitrogen. And you have got your water left here. And this comes out like this. This comes out and gets into a U tube. It gets into a U tube. Now this U tube is kept in a bucket of ice. This is ice. Now, if nitrogen and water are coming through this tube, U tube, what is going to happen? Water will get frozen. Correct? Water is going to form ice.
So easily.
Easily. Okay? Now, this is not ordinary ice. This is your carbon dioxide ice.
Dry ice.
Dry ice. Or you can use, it is, or we can say freezing mixture, where there is ice and salt. So the temperature of the ice is brought very, very low. Correct? So here we've got ice. And what is coming out here now? Nitrogen. So only fumes of nitrogen. Nitrogen doesn't get condensed. Correct? So nitrogen moves and it is collected by the downward displacement of nitrogen. Downward displacement of nitrogen. this is water. So it is upward displacement of nitrogen and downward displacement of water. So this is filled with water and this is nitrogen escaping. Okay? Don't follow my diagram, I'm just doing a rough diagram on the board. So pay attention here. Ammonia with copper oxide gives you copper. Nitrogen and hydrogen are coming down and are passing through a U-tube. The U-tube is placed in ice cold water. So water gets condensed. And what is escaping? Nitrogen. Nitrogen is escaping and is collected through the beehive arrangement. This is called a beehive arrangement. The beehive arrangement is like this, a beehive arrangement. And the tube passes through this way, a beehive arrangement. It passes through the beehive. Over this is kept a gas jar. It's kept a gas jar filled with water. So the water comes down and the gas is collected upwards because nitrogen is lighter than water and is insoluble in water. So it is collected by the downward displacement of water and the upward delivery of the gas. Yes or no? Follow? Read. Huh? No, I cannot tell you now. You continue only after October because they keep on changing the rating every year. So after October, they will send you a sample paper. We put on the site. From where you can, that is the final. From where you can calculate the rating. Okay.
Our teachers think that these questions will come in integrated form.
See, I don't think it's a very wise decision to say right now because the board changes its pattern. So you can come to know only after the after October. But not now. Now she's giving you her observation of the previous year. This year will change. Yeah. Come on, read properly. Another thing is why that ammonia is kept, that tube is kept so high because that reaction is exothermic. It can also be explosive. Hence, therefore, it's kept away from oxygen. Okay, very far away from oxygen, so that it can be burning under controlled conditions.
First process, is the temperature higher or low?
Optimum 450 to 500.
Yes, if there are only two options, either higher or low.
Yeah. And that is 500. Then it was high. 450 to 500 is high. But that's the wrong position. It's very high. It is exothermic reaction has to be favored at low temperature. Okay. Now there are two important equations that you have to remember. Reaction of ammonia with chlorine in excess of ammonia. Excess of ammonia. And there is reaction of ammonia with chlorine in excess of chlorine. Two reactions are there. Very, 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 very important. The first one, ammonia plus chlorine. Okay. What property did I explain to you just 5 minutes ago about ammonia? Reducing. So if ammonia is reducing, it is reducing chlorine. So what will chlorine become then? HCl. So it becomes HCl. So what are we going to get here? Nitrogen plus we're going to get HCl. Correct? Can you balance this equation? What will we get now? 2. 2, 2. 2 3s are 6. 6, correct? Then 6, that is 3. Am I correct? Correct? Now, excess of ammonia. I'm doing this one. Excess. That means you take more ammonia. Second reaction. NH3 plus 6 HCl. If you're taking 6 HCl, take 6 ammonia. What are you going to get? 6 ammonium chloride. This is what you're going to get. Cut this out. Correct? You have to cut it out. Therefore, you're going to get 8 ammonia plus 3 chlorine plus nitrogen, 2 nitrogen, get this right. Nitrogen plus 6 ammonium chloride. This is your final reaction. Do you understand this? Now I'm talking about this excess of chlorine. Excess of chlorine is what? Ammonia plus chlorine excess is giving you NCl3 plus HCl. You're going to get NCl3 plus HCl. 3 HCl, 3H, 3Cl. Okay, so you got 3Cl. Now there is 2. 3 2s are 6. 3 and 3 6. Balance it. Now this is trichloronitrogen, highly explosive. Yellow in color and highly explosive. Yellow in color and highly explosive. This is trichloro or nitrogen trichloride. Same thing. This one. You can remember, but I don't want you to learn it by heart. I want to know how exactly we are getting it. So I'm just showing you the step. is it better to learn the steps or learn it by heart? The choice is yours. I'm only explaining to you how you got this. You say this, how I got this answer. Suddenly 8 has come from where? It's come from the addition. Okay, it's come from addition. The teacher didn't do the addition for you. She must have done the addition for you. Huh?
She showed us that, but then she told us that we have to learn only the last one.
Okay. But you have to, I want to explain to you how you get it. Understood? All of you? Now, read till there. Read till there. Quick, quick, quick. 3 minutes to read till there. Very important reactions these are. Yeah.
Mom, if there were a question like NH3 plus O2, the catalytic
I didn't hear you.
if there was a question like NH3 plus O2, the catalytic oxidation of ammonia. So NH3 plus O2 gives NO plus H2O plus.
That is with a catalyst.
Yes.
And without a catalyst, there are two conditions. Without the catalyst, you're getting nitrogen and
Yes.
HCl. But here you're nitrogen and water. And here you're getting what? You're getting brown fumes now. So they will put the condition. Because under various conditions, it will give you different products. That is it. Finished now? Now we've got how, now what is the reaction of ammonia with HCl? Ammonia with HCl. Okay, but there was something I had told you about this. Ammonia. What is the physical state of ammonia?
Gas.
Physical state of hydrochloric acid, of hydrogen chloride?
Gas.
Gas. And physical state of ammonium chloride? Solid. So two gases giving you a, I told you this is never to be forgotten. It will come in this time's paper. How does ammonia react with HCl? Ammonia gas plus HCl gas will give you ammonium chloride solid. Two gases giving you solid. Two gases giving you a solid. Very strange reaction this is, but important. Now, how does ammonia react with HCl? So you got this. Now, how does ammonia react with HNO3? HNO3. What are you going to get now? Ammonium nitrate plus, okay, ammonia plus, ammonium nitrate. You're getting ammonium nitrate. And what do you get with ammonia plus sulfuric acid? Ammonium sulfate. Ammonium sulfate. This is dry ammonia. This is HCl is liquid. Dry ammonia, H2SO4 is liquid. So you're getting ammonium nitrate and ammonium sulfate. Now, if you are using liquid ammonia will be what? Ammonia plus water, ammonium hydroxide. You're getting something different. So here again, if you take ammonium hydroxide plus HCl, ammonium hydroxide plus HNO3, ammonium hydroxide with sulfuric acid, you're going to get water. You're going to get, what are you going to get? Ammonium chloride plus you're going to get water. Here you're getting only ammonium chloride. Because you have used only ammonia, you're getting only ammonium chloride. Here you have used water, so you're getting water. Here you're going to get NH you're getting NH4NO3, ammonium nitrate, plus you're going to get water. Here you're going to get ammonium sulfate, plus you're going to get water because you're using ammonium hydroxide. Since you've used water, you'll get water. So you have not used water here, you're not going to get water there. Correct? And finally, who put the fire? It's very hot here. Finally, if you're using ammonium, hydroxide for certain heavy salts, heavy metallic salts. Ammonium hydroxide is heavy metallic salt. What are the heavy metallic salts? We're getting Fe, ferrous sulfate, not ferric, ferrous sulfate, ferric chloride, zinc nitrate, then NO3. Then you get lead nitrate, NO3 whole bracket twice, plus copper sulfate, very important. 1, 2, 3, 4, 5. Those are heavy salts. Salts of heavy metals when they are made to react with ammonium hydroxide. You get the corresponding colored salts, colored hydroxy salts of these metals. These are all, this is green in color, this is brownish in color, white in color, blue in color. When you are mixing it up with ammonium hydroxide, you're getting the hydroxide compound, heavy metallic hydroxide compound, which are colored. So what are you going to get here now? FeOH whole bracket twice plus ammonium sulfate. This is greenish in color. This is FeOH whole bracket thrice plus you're going to get ammonium chloride, brownish in color, green in color. And this is your zinc hydroxide plus ammonium nitrate, NO3, white in color. And this is PbOH whole bracket twice plus ammonium nitrate, white in color, heavy and white in color. Where have I gone? Copper sulfate is copper hydroxide, blue in color, copper hydroxide plus ammonium sulfate. This is red nitrate comes here. PbOH whole bracket twice, white in color, plus ammonium nitrate. And this is zinc. Zinc OH whole bracket twice plus ammonium nitrate, white in color, zinc. Followed? These are the colors, very important metallic heavy salts. For that, finally we come to the uses of ammonia. Ammonia is used as an agent to dissolve grease, oil stains. Okay, it's like a detergent. It's used as a detergent to dissolve oil stains, ghee stains, fat stains. Okay, all of that. It is used as a cleansing agent to wash the bathrooms, tiles. Okay, fine. Then it is used for the manufacture of fertilizer, ammonium sulfate, ammonium phosphate, urea. That's a very important reaction. Urea is what now? Ammonia plus carbon dioxide. So getting urea. NH2CO NH2 plus water. This is urea for the manufacture of urea. Also, it is used as smelling salts. Ammonium chloride is used as smelling salts. Then it is used as a refrigerant. What is a refrigerant? A refrigerant is something that will keep everything very, very cold. Now, we have got this ammonia in our, actually, ammonia is not used in our fridges. Nitrogen is used. But in huge industrial plants, they use ammonia for getting ice, huge blocks of ice. The ammonia is used. Why? What is the property of the cooling property of ammonia? 1 mole of ammonia gas, which is at minus 33 degrees centigrade. It's already so low. It is in the liquid state. If it has to vaporize, it needs heat. It will take 5,700 calories of heat to vaporize. So you can imagine how much of heat is taken up by only 1 mole. So many moles of ammonia will cool down the atmosphere like anything. So you cannot enter the ammonia plant just like this. You've got to have covers and covers and covers because your blood will freeze. Huh? I didn't hear you. Minus 33 ordinary, and then it is still in the gaseous form. Sorry, the gaseous form, the liquid form. Liquid form. When it becomes gaseous form, to become gas, it has to need heat. From liquid to become gas, it needs heat. It will take heat from the atmosphere. How much of it? 1 mole only will take 5,700 calories. So that is how the temperature of the entire plant is reduced and you get huge blocks of ice. That is the cooling property of ammonia. And lastly, we have replaced ammonia by previously what we were using chlorofluorocarbons. What is chlorofluorocarbons? Chlorofluorocarbon. This was a cooling agent. Now what happens is this chlorofluorocarbon, in the presence of ultraviolet rays of the sun, breaks up into chlorine, monochlorine, monochlorine. Chloro, meaning monochlorofluorocarbon. Monochlorofluorocarbon. Plus, okay, this is what you get. Now this, okay, what happens is Cl, yeah. Now this ClF2, okay, plus you are getting your chlorine. This one chlorine is here. This one chlorine, 2 was here, 1 is here and 1 is here. This chlorine is said to be atomic. This is atomic chlorine. Highly reactive. Now this atomic chlorine goes and attacks the ozone layer. What is the ozone layer? It is a covering over the atmosphere to prevent the ultraviolet rays of the sun to attack us. This is attacking that layer, taking a hole in it. What are you getting? You're getting ClO plus O2. Correct? Now this ClO attacks atomic chlorine, oxygen, and what you're getting? Cl plus oxygen. This monochlorooxygen attacks an atomic oxygen and you're getting chlorine plus oxygen. This is atomic chlorine. It goes and attacks oxygen, ozone again. And that is how this process is continuing, with the result the ozone layer is depleting, resulting in the bad effects of the ultraviolet rays on our skin cancer. Okay, that's the end. Read this chapter. Ammonium with NH4, ammonia and NH3. See, like this it is. I got this out. See here. Ammonia is NHH, correct? Correct. So you have got your ammonia, okay? And you got 1, 2, 3. You've got your hydrogen. You got your hydrogen. You got your hydrogen. This is ammonia, correct? Okay. Now this is a lone pair. This donates it to another hydrogen ion. Correct? So this becomes the donor. This is the donor. This is the acceptor. Acceptor. This is ammonium NH4. That is the difference. Ammonium 4 hydrogen atoms. That is ammonia 3 hydrogen atoms. That is a gas. NH3 is a gas. NH4 is a radical. It has got a charge. This whole thing is positively charged. NH4 positively charged. Hydrogen is a proton. Okay, that charge goes on to ammonium radical. Follow? Is there any part of the chapter that some of you have not understood? You're not paying attention or you're fast asleep? You can pack up your bags now. Go if you want to finish. Can I finish? Do you want to go? Okay.